bondflation in today's society. All right, let's go live on TikTok. Let's go live on YouTube. And then let me get my chats going. What? You can't find my... I'm definitely... You're hoarding bond coins. I'll keep giving them to you, dude. I mean, like, they're legit. Like, you did earn them. You can do whatever you want with them. If you want. We should be streaming. What the fuck? Okay, Pineapple, because I don't see anything in the queue. If you want me to help you out with Chem, just the easiest way so that I know to help you and, like, if there's a queue of things going up, there is a website called actualofficehours.com right here. One day I will overthrow the channel. Yeah, maybe I'll make it so if you send enough bond coins, you can replace me. Try to go there and to submit a screenshot. So here under the actualofficehours.com, just put your username in, drop an image in, hit upload. Just something. Oh, I see it. Nice. Lucky Cat and Gladiator got in there literally 6 seconds after you. And this is kind of fun. Look at it. Look at the timing on this. 5:15:07, 5:15:13. Wow, 6 seconds. Okay. I do not know why. Yeah, we are connected, dude. Yeah, good. Yeah, there's my stream key. I want my YouTube chat to work. It's critical for me. Here, let me delete this one. Let's remove that. No. Not picking it up. I might have to, like, update this. The fuck? Alright, let me create a new live source. YouTube video ID. Okay. And let me see if it's working. Test. Good. There we go. All right, cool. 6 months after the guy was at 7 seconds. Surprise,
motherfucker.
Oh, no, dude. Yeah, it starts again. Okay, here. Let's do this. How solid-state batteries differ from lithium-ion batteries in terms of operation, chemical compounds used, and reactions. Oh, crazy. I actually have no clue about this, but I'm going to learn it with you. I thought you had, like, equations that you had to solve and stuff. Like battery equations. But, okay, we can try it out. We can learn some stuff today. Solid-state batteries differ from lithium-ion batteries. Is solid-state batteries like nickel, like NiMH, like NiCad, nickel metal hydride? It's the same? Wait, I would think like lithium-ion, like Lion, is the same as well. Okay, well, whatever. Let's use ChatGPT and learn. I can do electrochemistry questions. I can definitely do that. But let's learn. You know, I'll learn something with you as well. Okay, lithium ion use a gel or electrolyte that allows lithium to move between electrodes. Cool. Right? So lithium Li plus is positive, and they say it moves from the anode to the cathode. Now the anode is usually negative. Why would ions move from a negative side to a positive side? And electrons move through the external circuit. This is like against a gradient, I feel like. During charging, the process reverses. A liquid electrolyte requires a separator to prevent short circuits. I think solid-state batteries are what we're used to doing. This is the classic, you know, you have two electrodes and you have it like in a solution, and then there's a salt bridge. So solid-state batteries replace the liquid electrolyte with a solid electrolyte. Lithium ions move through a solid crystal instead of a liquid. Okay. No liquid means less risk of leakage, fire, and thermal runaway. Nice. Okay. Compounds used. Okay. So yeah, the cathode is the positive side, right? Because that's where the lithium is. Okay. And that's where the lithium plus comes from. I think the lithium plus moves towards the anode. Because especially if, you know, if we were to think of... Ugh, where's my pen? Why are you stuck? There we go. We just get like a classic like battery diagram or something, whatever. But like from electrochemistry. This is the classic battery that you learn in chemistry. Where, yeah, usually you have a cathode, which has some sort of metal or something, and that will end up giving off positive things, right? Yeah. Well, this is positive, right. Wait, why are they saying Ag plus? Ag plus. Wait, this is the other thing. Okay, sorry. Anox, anode oxidizes. Cathode reduces. And what that usually means is if an anode oxidizes, it loses electrons. Cathode reduces, which means it gains electrons. Notifications alert: your YouTube account will be suspended for violating YouTube policies. End the live immediately. That's a pretty fun bot. Who's this? Let me see. Should I add you as a moderator, dude? Let me go to this channel, dude. Yeah, not legit, dude. I'm gonna report this person though. Anyways, and then a cathode reduces, which means it gains electrons. This is in general. So here, Pineapple, my question for you is this a high school class? Like, what are you doing? I don't think I've seen questions about lithium-ion batteries in a high school chemistry class. It is a high school. Oh, okay, interesting. It's definitely not on AP chemistry. I don't know. Oh, it's Ontario. Oh, it's Canada. It's Canada Chem. Funny chemistry. Do you understand how... No, he's trolling, Alistair. Yeah, no. The account was made in 2015. I don't know how he found my account, though. Who am I talking to? People in the chat. That's just general people in the chat. You can see them. Oh, on Twitch? Yeah. Well, on Twitch or on... we have on Discord. We also stream on TikTok. I haven't seen anything from TikTok, actually. Ooh, wait, yeah, what's happening with TikTok? Why have I not seen a TikTok thing yet? There we go. That should connect now. Aha, okay. Nice. Yeah, okay, so this is the classic idea of what a battery is. So you're not allowed, according to Twitch's terms of service. YouTube doesn't give a shit. YouTube would love for you to stream on as many platforms as possible. Like, yeah, YouTube doesn't care. They're trying to like they're trying to make like a headway into the streaming game, because YouTube just started as just mainly just having like videos. That's all they did, and then they slowly got into streaming. Okay. So, and then in terms of solid state batteries, I guess it's just the interface is what they're saying. Yeah, here we go. Let's see. Let's say at the high school level, what is help on graphing rational functions. If you want to submit a question there, Sako Nako, the website to do it is right here, actualofficehours.com. If you go to that website, type in your username, drop in a screenshot of a rational functions question you want help with, and I'll do it. I'll do it here live on the stream. Oh, I see. High school electrochemistry is more galvanic cells, which uses oxidation at the anode, right, and reduction at the cathode. And then they say that, yes, good lithium-ion and solid-state batteries follow the exact same model. Okay. So, interesting. So here they say, yeah, the anode is during discharge. Okay, lithium is going to, yeah, and this is what we talked about, right? So, at the anode, I do know the squeeze theorem, Spencer. Yeah, for sure. I do a lot of calculus. The anode oxidizes, and oxidizing is losing electrons. The cathode reduces, and that means it gains electrons. So in a lithium-ion battery, that means lithium becomes lithium plus by losing an electron. And then on the cathode side, lithium ions gain electrons and are incorporated into the cathode material. Okay, cool. So lithium-ion Li plus, I guess, like, reacts with this electron to then form solid lithium. The difference between battery types is not the redox data, but where and how the ions come from. There's a website right there, actualofficehours.com. If you go to that website, you can see it. Okay. I need to self-study calculus this spring. What resources do you recommend for doing this? Ooh, good question. Calc 3 is intense because that's multivariable. So you're dealing with like Green's theorem, Stokes' theorem. I really like Paul's math notes, Univator. Yeah, and he has a great website. And actually, this is actually a good time for me to kind of like plug. The same website, actualofficehours.com, that I talked about, where you guys can submit your screenshots. This one right here. Also has a link to join our Discord. And so if you go to our Discord, this is our Discord. We have a channel here called Useful Tools. I did this because someone suggested it at the end of the year. At the end of the year, we had a survey for the whole stream and the whole Discord, and people said, hey, could we have a channel just dedicated to tools? So I did do that. So here under like Useful Tools, we have a bunch of websites that I think are really good and other students have suggested to me for, you know, doing math, science, or whatever type stuff. For like study help and learning, Paul's math notes. I love Paul's math notes. What's up, JC? So there's a link here to click on it. And he has stuff on like Calculus 3. So here you go. Here's Calculus 3. So notes, practice problems, assignment problems. Did someone say chemistry? JC, someone did say chemistry. Yeah. I'll show you the question in a second, JC. But for you, Univator, I would definitely recommend like going through this. So here, if you click on here on notes, yeah, these are all the things you need to know in vector calc. Yeah. 3D space, arc length, that's a big one. The different coordinate systems, partial derivatives, and then how you use the partial derivatives to do, yeah, Lagrange multipliers are cool. And then so it's interesting, Calc 3 goes through some advanced multivariable, so instead of dealing with just the x and the y coordinates, you start dealing with like z and like t. We start doing derivatives with more than one variable, and then you start doing integrals with more than one variable. And when you start doing integrals with more than one variable, there's a lot of really cool like theorems that come about, such as like Green's theorem and Stokes' theorem. And these are theorems that you will use, especially if you start going into like more advanced physics. They become super handy for solving difficult integral situations. Stokes here, yeah. Oh, dude, look, Ryan Stokes. Yeah, we got have an actual Stokes in the chat, dude. What's up? So yeah, so Stokes theorem. Maybe it's his theorem. Ryan, is this your theorem, Stokes theorem? So yeah, Univator, that's what I would recommend. I would recommend to go check out Paul's. Well, join our Discord. And if you want to self-learn, there's a link there for that. You can also ask questions about Calc 3 when you're doing it to, get some help. The divergence theorem. Yeah, that's another great one. I like the fundamental theorem of calculus for more than one variable, which I think is basically Green's theorem. Is what it is. There's a lot of cool ones. Yeah, Univator, you're more than welcome. Anyways, let's see. So yeah, for you, Pineapple. So just to wrap this up, I think the only difference, and here I'll show JC. JC, this is what the question. It was kind of an open-ended question. It wasn't like a specific one, but their teacher was asking how solid-state batteries differ from lithium-ion batteries in terms of the compounds used and the reactions. So I think the reactions are the same. Yeah, Electrochem, get that out of here. I like Electrochem. Electrochem's fine. But I think the reactions are the same, Pineapple. The only difference between solid state and like lithium ion, which to me I think they're kind of the same thing, is the medium. So lithium ion has a liquid in between, whereas solid state, the ions move through a solid. I think that's literally all the differences. If you have some like actual questions based on it, you can submit those. I can try to go through them. But yeah, here's the one sentence classroom summary. It's an interesting one. But I love all sorts of questions. Interesting, non-conventional, conventional. The reaction's the same. Yeah, it's the same oxidation reduction reaction. So here, I think it's just lithium plus an electron becomes lithium, and then lithium goes to lithium plus an electron. Just depends on the sides. We can ask chat. Let's just see. I'm curious. I think it's literally just gonna be lithium goes to like lithium plus. Oh, and then there's carbon, I guess, involved. Sure. Oh, and cobalt. Okay. So here you go. So this is so yeah, all sorts of electrochemistry is they're redox reactions. Someone was asking me in the server actually earlier about redox. And then so yeah, for solid state, I think because you don't have any sort of like liquid, you're not gonna have any specific like reactions. Yeah, I think it's literally just this. Yeah. So for solid state, the equation is literally just like lithium goes to lithium plus. Like there's nothing else involved. You don't have any liquid in between, such as here, right? This is an example of a galvanic electrochemistry battery. Here you have like liquids, and so you have some. Again, this is called a salt bridge. You have some other intermediary material that's carrying the ions. Yeah, there you go. Ryan Stokes, yeah, he put it pretty well here in our chat from TikTok. He says, there's no reaction, thin layer storage, there's no volatile elements. Yeah. It's literally just electrons going back and forth between an anode and a cathode. Whereas for this one, right, for lithium ion, you have some intermediary. In this case, it's like, looks like, I don't know what, cobalt oxide? Cobalt dioxide? Is that what we call it? Yeah. You've learned this from chemistry? Yeah, I've done the electrochemistry part for sure. I don't think I've ever seen, and again, the 10 years that I've taught chemistry at the AP Chem level, I don't think I've ever seen questions about lithium ion specifically. Yeah. No. Well, I mean, it could be a bunch of different types of liquids, but it's generally, it's one specific liquid. Yeah. Yeah. Spencer says a lot of times the intermediate is only carbon. Okay. Or I guess, so carbon is graphite. So I guess that's not a liquid in that case, right? Yeah. I don't think, yeah. The teacher that the teacher that taught you online got you this reaction. All right, let me see what the reaction is. Solid sodium ion. Sodium is volatile. Is used to conduct energy as a solid in the other types of not galvanic. Yeah, okay. All right, let's see. This is what his teacher gave him. Peacing out, Ryan. It's taking a while for this thing to load. It gave me a very high resolution image, apparently. Anything is better than cobalt. Okay, here we go. All right, let's see. So this is the most high resolution image I've ever seen. I can see like the banding on the... I can see the individual pixels. Okay, here we go. So lithium ion, 10 million pixels. Lithium ion battery reaction. Sure. And so, yeah, this is the carbon that Spencer and Ryan were talking about. Lithium plus carbon goes into some other lithium and carbon. I guess there's another one here as well. Oh, interesting. Why are there two? This is actually this is a weird reaction. The dirt on the screen. So yeah, I can't tell if that's my dirt or the dirt from the picture. Oh, an M can be cobalt. Okay, so you're saying that this here, right, could be cobalt. Or CO. Sorry, CO. Like that. But the main thing is, right, yeah, so the positive electrode, which is the cathode. I'm trying to relate everything again to galvanic cells. Wait, isn't the cathode is reduction. Reduction is gain in electrons. This to me looks like you're losing electrons though, no? Yeah, red cat. Yeah. So, but if this is the anode, then, right? The top is the anode. Oh, okay. I thought the cathode's always positive, though. I agree that the anode, yes. yeah, there's some debate here about this, right? No, I thought, wait, what the fuck? Yeah, the anode is negative. Okay. Yeah, they try to trip you up with the charges. Exam tomorrow, gang. I'm cooked. Best of luck to you, Maddie Waddy. You still have a whole day before your exam tomorrow. Yeah, let me ask like chat because I'm curious about this actually. I'll be like, oh, this is teacher gave me for an example reaction. Classical mechanics. So college level physics, or is it an upper division physics class? I'm gonna say I thought the cathode was positive, but should also be the site of reduction, which would be a gain of electrons, but oh, you know where? Okay, I know exactly where this is. Yes, yeah. This is the issue here. Oh, this is so funny. You know where I was getting confused here, Pineapple? It's because of charging versus discharging, dude. Man, that's so mean of your teacher there. Okay, fuck. So whenever we speak about batteries in this sense, right, the galvanic sense, galvanic cell from chemistry in AP Chem, these are always discharging. These are always discharging batteries. So, the reaction for discharging a battery is going to be opposite for charging a battery. So in this case, this does make sense. This is the cathode. And then this is the anode. Because when you discharge... Yes, yeah, but yeah, exactly, right. Yeah. So when you're discharging, the cathode is reducing, and means it's gaining electrons. And that's what's happening here, because in the discharging way, which goes from right to left, you're taking lithium plus, you're adding an electron to it, and you're getting lithium neutral. Whereas with an anode, you're going to be oxidizing, which is losing an electron. And so in this case, discharging is moving this way, and that's why lithium neutral loses an electron and then results in lithium plus. Okay. Yeah, the charging and discharging was like, I don't know. It's starting to like mess me up, dude. What?
Huh?
Okay. All right. Queue's getting pretty long, so I hope this helps Pineapple a little bit with like a general overview of how electrochemistry and batteries work. I think, again, the main important things that your teacher is probably going to ask you about are these things. So just always remember that, like, this thing is negative, this thing is positive, this oxidizes, it loses electrons, this thing reduces, and it gains electrons. And then from there, the only difference I really see... Yeah, Spencer has a really good one. Anox, red cat. Yep. This is always a good one. Anox, red cat. So anode oxidizes, cathode reduces. Should help you out with memorizing things. And then just the differences between them is, I think, just the intermediaries. So this has like some sort of, I would say almost like liquid intermediary, whereas solid state, I think, is just literally lithium going to lithium plus. All right, you're very welcome. Nice. Okay, cool. All right. Good job. What's up, dude? Is there Shantrix? Maybe. This was literally the first question of the day, so let me
Oh wait, what? Oh, so
yeah.
I just joined. Like, this is a rare occurrence. I don't ever join in the beginning.
Well, I spent 15 minutes just yapping about, I don't know, life and stuff, because we didn't have any questions in the queue. Now there are questions. So you're very welcome, Pineapple. Pineapple says thank you for yeah. We have people from YouTube, people from TikTok. This is great. I love bringing the community together to have you guys all help each other, and I learned some shit along the way too. So I appreciate it, Spencer. Also, all you guys. Yeah. Anybody know Ostrogaski's method? I do not. All right. Where's Discord? All right. So I'm gonna put this question into. So I'll put I'll put a screenshot of everything we kind of went over into our Discord under the what is it, the question. There it is. Homework help. That's what I want to do. All right. And then we'll move on to the next one, which hopefully is a nice one. What's up, Justin? How's life?
It's something.
It's something, he says.
It's always something. Life is something.
It's better than it being nothing, dude. Yeah, if life was nothing.
Yeah, exactly.
Yeah. We'd be kind of bored. All right, there we go. Let's pull this in. You missed out on Fall Guys, dude. Did we play Fall Guys on Friday?
Yeah, I'm not really. I haven't played Fall Guys in like 4 years.
I hadn't played Fall Guys. I hadn't played Fall Guys since fucking, was it COVID? And it was really fun. It was, yeah. They added a lot to it. Let's see, what is... Oh, this is fun. A little domain range question. All right, let's see what we got. Sin City wasn't made for you. Sin City's cold and empty. No one's here to judge me. What? I don't think I ever saw that film. It has Bruce Willis in it, no? Fine GF? What's that? The other thing, the funny thing is this is like F of G. It's like a fog. It's kind of... What's a GF? Okay. All right. Let's see. All right. For the following functions, determine the defining function f of g and g of f and determine the domain range of both. Okay. So f like this, I believe is f of g of x is what it is. And so all that happens is you put g of x wherever x was for f of x. So this would be 2 to the square root of x minus 1. And then g of f of x. Got class starting tomorrow. No, stop. You can't escape it, daddy. You can't. Daddy thick legs? Wow, dude. That's actually... I did squats yesterday. All right, so then this would be the square root of 2 to the x minus 1. Very interesting. 2 brackets after the x. You're on my FYP again? Yeah, you can't escape me, dude. My bizzles. 2 oh, after this one. Sorry. Yes. Okay, domain. So, I mean, I made a video about this, but anytime you're asking about domain and range, you're basically just trying to see what values, when I plug in for x, do I either take the square root of a negative number or, like, divide by 0 or, I don't know, do some weird shit you're not supposed to do in trig. Yeah, so domain is almost always all real values of x, unless you start seeing like this type of stuff. When there's square roots being involved, now we gotta get a little bit more tricky, okay? And the main thing here, right, is that this part right here, whatever's inside has to be greater than 0. Okay, so I look at this and I say, okay, just set whatever's inside there and say that this has to be greater than or equal to 0 and then solve. And so what that tells me, right, is that x has to be greater than or equal to 1. Has to be. Okay. So then the domain, we would say, is from 1 to infinity. Right? There you go. And then when I see that, I like to... Yeah, dividing by a trig ratio. Exactly. Yeah. Or if you're doing like inverse trig stuff, right, where you're outside the bounds, that'll also trigger it as well. Hard bracket on the 1. Yes, you're right. Sorry, it can equal 1. Thank you, Jeff. Totally correct. Yep, I forgot about that. That little bit there, yeah. So because it can equal 1, we put a bracket. Nothing can equal infinity.
No.
So you always put a parentheses. The range is the y values. Correct. Yeah, so this is a domain. So let's look at the range. Let's just see what could happen. So I always, this is 2 to the something, right? So if I have 2 to the something, what's possible from that? Well, I know if this, for instance, were like a negative number, let's say this was like 2 to like the negative 50 or something, that would basically be 0, because that becomes 1 over 2 to the 50. However, no, you can't have a negative number in the top here, because we're taking 2 to the square root of something. So I really like looking at this almost from a coding standpoint, like thinking, what's going to come out of this, and then how is that going to affect the next thing? Like, these are all, I mean, literally they're functions, right? Like, I have the function square root of something, and I know that square root of something will always get me something from 0 to infinity. It has to be positive. So, and then 2 to the something, right, will never give me a negative number, because 2 raised to any exponent has to be also positive. So right away, I'm like, okay, well, this has to be probably at least 0, or right? It can't be negative. But then I see that there's no way to get a negative exponent here. So the smallest this exponent could be is 0, right? Because the smallest the square root of anything can be is 0, and then 2 to the 0 is just 1. So that tells me the range starts at 1. And more importantly, it can equal 1, right? Putting 1 in for x is totally valid. Yeah, exactly, Spencer. Yeah, you plug in the lowest number of x from the domain to get the range. That works, unless sometimes you get like spikes, right? Maybe it's like on one extreme here and it's one extreme here. Thanks, Trollcats. It's almost done. Well, I mean, it's kind of just started, but yeah. Okay. So then to infinity, right? Spencer's right here. If I want to do 2 to the infinity, well, 2 to the infinity is just infinity, right? It's just 2 times itself, like an infinite amount of times. So in this case, the range is 1 to infinity. Okay, let's look at this one. So again, domain, the big scary monster here is the square root. So I know whatever's in the square root has to be greater than or equal to 0. So I'm gonna say 2 to the x, so the entire thing. I just blank write this. I'm just like, hey, this thing, that whole thing has to be greater than or equal to 0. It didn't specify the notation. No. So I'm going to say that 2 to the x has to be greater than or equal to 1. And, I mean, I know the answer is 0, but if you wanted to show this, like, formally, the way to get this thing out of the exponent is to take the log of both sides, right? And so this would become x ln of 2 is greater than or equal to, and then the ln of 1 is 0. So then x is greater than or equal to 0. Cool.
My man. So,
yeah, for this one, domain is going to be from 0, and then there's no problem with this going up to infinity. Will you be the hole to my asymptote? Are you busting out the Valentine's Day stuff already? Is it always greater than or equal to, or is there cases where it's only equal to? So, when it's... I think what you meant to say, are there cases where it's greater than or equal to, or when it's only greater than? There's no case where it could be greater than 0, but then it's only 0. But there are cases where it can be 0 and greater than 0, or it can't be 0. I'll show you why in a second here. And then the range for this is pretty easy, right? We're just taking the square root of something. That's going to go from 0 to infinity. Yeah, so, Gladiator, you bring up a good point. So, because this is the one that will... Oh, sorry, I went back accidentally. This is the one that will, like... Here, this is, like, tricky. This is the one that will trick people up. Is, for instance, if they said 1 over the square root of x minus 3. Let's say this was our function, right? So, off the bat... You could say, okay, wait, the square root thing. I need to make sure whatever's inside the square root is greater than or equal to 0, right? So I would say, okay, cool. X minus 3 has to be greater than or equal to 0, so x must be greater than or equal to 3. Yes. Sorry, you're right here. Yep, yeah. I'm making small mistakes. Thank you, Shantrix. Yeah, this is greater than. Sorry, this is equal to. Yeah, exactly. Spencer says, when you're composing functions, think about the function that you're putting into the other function because you're getting rid of the other one. So in the first case, think about the restrictions of g of x and f of x for both of them. The square bracket means it can equal it. The half bracket means it can't. So, and this is the example here. So in this case, yes, anything greater than or equal to 3 ensures that I don't take the square root of a negative number. But, however... If this is equal to 0, I'm in trouble. No. Because you can't do 1 over 0. So this is a case of where x has to be not only greater than or equal to 3, it has to be just greater than 3. So this one doesn't work, and so we say, yeah, right, but no dividing by 0. So you would just say x is greater than 3. And then the way to write that in whatever interval notation is this, 3 comma infinity. This is greater than 3. This is greater than or equal to 3. But this is wrong. Wrong. Cool. What if you had 1 over the square root of x minus 6 times the square root of x minus 7? Are you putting another fucking 6-7 joke in there?
Obviously, don't go and do that, please.
Now, you do whatever you like.
We can't condone anything of the sort.
No, we can't. Live! Live!
We left that in 2025. Yeah, okay. All right. Does this make sense? Leo? Gladiator? I think we did a good job for this one, right? Yeah. This was like a little side example. Yes, okay, cool. Nice. Great. Good question. You have to be hyper aware for the 6-7s, dude. The 6-7s come up all the time. They're there all the time. Although Jeff is doing God's work. The more we push 6-7 into the cringe land, the less it will appear, you know? We millennials and Gen Xers have a duty to kill 6-7. All right. Let me see. You had another one. Okay, this one's physics. Here, Gladiator, if you can I do Star Prod Spencer's and Shantrix's real quick, and then I'll come back and do this one? Just to make sure I get one from everyone. This is a great question, though. I like this. Okay, cool. Thanks. All right. Star Prod. What do you got for us? Ooh. More optics, my favorite. Oh, brother. I fucking hate optics. Because I always get it wrong. Okay. All right, here we go. I'm going to have optics for you until Friday. It's okay. It's not your fault. It's just what happens. Like, sometimes your teacher just gives you optics questions. Okay. Yo, what's up, Mathematic Fanatic? We should do that with other cringe memes like marketism. What's marketism? One of the other tisms. All right. A convergence lens, the objective, and a divergent lens, the eyepiece, as illustrated. The distance between the lenses is that, and the focal lengths are 9, 20, and 51, respectively. Okay. So I guess this is the second thing then, no? Because if the focal length is 920 and the distance is 9... Well, actually, the distance is 970, right? This is 970. This could be the 920, right? Because it's 920 away. And then I think this is the 50, right? Because otherwise they would be right on top of each other. If this was 920 and this was 50. Thank you, man. I hope... yeah. This is optics, is what it is. Yeah. I agree. I think the objective is F1. I'm gonna agree with you there, Star Prod. And I think this is F2. Kind of interesting, right? This focus is like inside this focus. Calculate the size of the intermediate image of the ISS formed in this telescope. Oh, okay. So, this is where I need to remember, dude. Okay, you know what I'm doing? I'm going back. I'm going back to, because we did this. We did this on the stream last time. Here we go. Yep, this is what I want. Because I always forget, like, which one is negative and which one is positive. Right? And I think I still have this messed up. The nice thing I know is that that's positive and that's negative. Let me see. Object on left, eye on right, Cartesian sign convention. Uh-huh. I'm gonna go with this. I feel like I like this. I like this. It seems real to me. Also, it kind of goes with my idea of if you're measuring in the same direction as the light, then it's positive. Yes, divergent is negative for sure. Yeah, so this is positive. Oh, I lost it. Jeff, the TikTok chat has some answers for you. Mirrors? No, these are lenses. Okay. And then size is magnification, right? And then magnification, I want to say is DI over DO. I think it is. Yeah, it is DI over DO. Cool. I forget, but it's negative. It's negative. Yeah, it's negative image over oxygen. Yes, it is going to be the height. So the height is going to be... So... But then this is related to, right? So magnification is also equal to the height of the image over the height of the object. Right? Yes. Agree. Good. Okay, fine. Love it. My question here though is going to be whether DI is negative. Thank you, J-Shack. I do need to drink water. I don't think we partied enough. You look up. I need to look a bit dehydrated. Yeah. Okay. All right. So this is the object distance, right? So we can say that. And then this is the formula I think we're going to use. We're going to say 1 over DI, and I'm going to say plus 1 over DO is equal to 1 over F. Right, and in this case, DO is equal to 36,000 kilometers. Yep, I agree. And then we're going to figure out DI. But then I know that F is going to be equal to 920 times 10 to the minus 3. Right? Okay. That seems pretty reasonable. So let's get some numbers in. I need my gold calculator, though. Where's my gold one? Okay. Okie dokie. So, 1 over 920 e to the minus 3. That's 1 over f. And then we're going to subtract 1 over the object distance. 10 to the 3. Meters to kilometers to meters would be 10 to the 3. Right? So I'm going to... it would be 36 times 10 to the 6, though. You are right about that. It's 36,000 times 10 to the 3, but it's also the same thing as 36 10 to the 6. Yeah. Okay. Yeah. You want to meet them both at meters. Oh, I see. You were thinking about going both to millimeters. Let's keep it at meters. Okay, so that gives me a number, and then I'm going to do 1 divided by that number to get the... So I'm 920 millimeters. Cool. Oh wow, that's exactly interesting. That's at the focus. Did we do that right? Oh, it's just such a small number. Oh, that's funny. This okay. You want to know why, Star Prod? Because this object distance is pretty much infinity. Exactly, right? Yeah. So the focus is literally where the image is going to be created. I don't think we even... those other digits aren't even, like, significant. Okay? So, in that case, we can say, okay, cool. DI is equal to 920 times 10 to the minus 3. And then, distance of the object is equal to 36 times 10 to the 6. So it's going to be really, really tiny then, won't it? That's F infinity on a camera. Yeah, I think it is. I think that's infinite focal length, yeah. So, magnification is... Dude, this is basically 0. Okay. 920 times 10 to the minus 3 over 36 times 10 to the 6. And then this is equal to the height of the image, which is what you're solving for. Or sorry, well, yeah, height of the image is what you're solving for. Over the height of the object, and the object height is 42 meters. This is going to be a very, very small number. Okay, so 920 e to the minus 3 divided by 36 e to the 6, and then times 42. And then, I don't know, we can divide that by... Yeah, maybe. Because then what we get from there is, that's going to be 1.07 micrometers. Microns, I guess. Okay. That's very small. Okay, but then, it needs to go through the eyepiece. Correct. So in this case, you're going to have 1 over di plus 1 over... So if this is at the focus, but this whole thing is 970, then this is a distance of 50. Say stuff about chromatic aberration. Isn't that the, like, kind of the wobble in spherical lenses? It causes the edges to look pretty weird or something. And then this is a diverging lens. So it's going to have negative focal. So then that's 1 over... So negative 1 over 51 times 10 to the minus 3. Okay. So... Uh-huh. Well, that's how, like, yeah, it forms rainbows and stuff. Okay. So then we're going to just move that over, I guess, right? So what? We have 1 over 51 e to the negative 3 plus 1 over 50. Then we're going to make it negative. In physics, no. Generally not. No, physics doesn't really give a shit about sig figs. It's just... Sig figs is a simplified form of error analysis. Yeah. That's what I would say. Like... It's like... It's the lazy ways... It's the lazy man's way of doing error analysis. And that's why teachers do it. Because it's just easier to understand. Yes, there you go. Thank you, JC. Sig figs is a social construct. It's like a conspiracy. It's a cheap hack that we teach students just so that they don't write like 14,000 fucking digits after their answer. Yeah, well, I mean, there's a reason for it. So for me, like, my mental head game is just always put like 3 decimal places, and you're probably okay. All right, so in this case, di is equal to 0.025 meters. Okay. And that was negative. Which is interesting though, because that means it's going to be on the left side of the eyepiece, no? Right? Isn't negative image distance over to the left? But I guess they don't care about the numbers. They don't care about the sign. They just want the magnification. So then di over do. So that's 0.025 over 1.07 times 10 to the minus 6. Right? Oh, wait, no, that was hi. Sorry, my bad. Sorry. 0.025 over 0.005, right? Yeah. Oh, cool. So that's just going to be 1/2. 1/2 the magnification. Wait, so it's still small. Wait, what? It's still really tiny. That makes it smaller. All right. Let me see. Let me see what chat says about this. I'm just curious. Good old magnification just messing me up. Let's see. It could be a poorly designed question too, honestly. But I'm pretty sure because the distance is so far that the image distance is literally the same as the focal length. Thanks, Leet Cyber Mage. Oh, Windows V has a clipboard history? Oi there, bruv. Top of the morning to you. I just want to see what chat does. Oh, you need... Okay. If you submit a screenshot, 30 on 30, we can help you out. The website for that is actualofficehours.com. So, there's not too many people in the queue, too, if you want to submit it. Just type in a username, drop a screenshot of a homework question you have. Dude, why is chat choking on this, dude? This is not that hard. My friend was doing an assignment in class, and he said, let me ask my best friend, and he opened ChatGPT. I mean, low-key, chat is the friend these days when it's kind of hard, I guess, to make friends. I don't know. Everyone's, like, kind of in a weird place socially. I think COVID really messed us up a lot. I'm a pretty social person. I can make friends with whoever. But I've noticed more and more that interactions with people are more difficult in real life. Like, people don't know what to do. They kind of bug out. Just like fucking ChatGPT's bugging out right now. Dude, come on, dude. Not... Okay. Here we go. Yeah. Corporate AI is not a good mass friend. What do you mean mass friend? Okay, look, it got the same thing as I did. Look. So, this is why I do like AI, because it makes me realize that I'm not fucking crazy. I'm like, yeah, okay, cool. It's 1.0... I think I said 1.06 microns. Oh, no, I said 1.07. Okay, so we're good. So I got the same answer there. Okay. And then we did this. Yes. And then this is also what I did. Yeah. So we should have gotten 25.25. And what did I say? I said it was basically 25. Whatever. It's close enough. Oh, so it is still small. Yeah, it's still very small. A physician? I'm a physicist. Yeah, physician is different. Thank you, Shantrix, for it. Okay, so it is a half. It is a half. No, I was right. Okay, so I'm not crazy. So, yeah, the final image height is then this incredibly small number, right? 0.542 microns. Which I think is all they asked about, right? ChatGPT goes one bit further to talk about the angular size. And I guess this is comparing it to in your own like sphere of space, like how far it would appear at the same distance, I guess. Yeah, don't worry about the angular size then. Okay, so then this is just what you want. Yeah, the final virtual image is what we said it was going to be. It's basically half of 1.07 microns. So it's 0.542 microns, and it's located basically 25 millimeters in front of the eyepiece. Yeah, and it's virtual. And that was right. These are all things that, again, I didn't think I was correct. I thought this was like kind of weird, but it turns out I'm okay. So whatever, you can do this. 0.0252. No, we'll say whatever. It's about a half. And because you have negative image distance, right? That means that the image is over here. It's a virtual image here. Yeah. Okay. So this is like the final image. Okay. ChatGPT is a good friend because it reassured me I'm not crazy. I was looking at this. I'm like, yo, am I okay? So final HI is equal to basically 0.53 micrometers. About 0.535, I would say. And then it's located 0.0252 meters to the left of the eyepiece. Where do you send homework? There's a website. There you go. Thank you, Jeff. Thank you for telling. Yeah, appreciate you guys. So yeah, that's where it is. I think that's all you need to know. I don't think you need to deal with like the angular resolution thing. Yeah, this is kind of more of a angular. I don't think you need to know angular magnification. I actually don't know where this comes from. I think you just need to know this. Does your website... The back end for my website is PHP. It's very simple. Trust me, Mathematic Fanatic, I keep getting all these like ads on Instagram about like, you need to be using Supabase and Cursor and I don't know, this and this and this and this. And it's just all these funny vibe coders using the same... whatever vibe coding AI platform things are like, this is your front end, use this for your back end, use this for your authentication, use this for this, use this for this. And I'm like, cool. It's very interesting. I don't think I'm gonna go learn it. I come from the school of like actually coding things, so for me, like, I think it's powerful. I think it's very powerful nowadays that people can do basically the high level coding jobs that would usually require a team of people manually writing code by hand. They're understanding how to do it more from like a software manager level. Like you have like agents that are doing this stuff. You're not actually doing any of the coding, which is crazy to me. But yes, yeah, Supabase. I don't even know what... I literally heard about Supabase last night as I was trying to go to sleep, doom scrolling. I just got caught in this like algorithm of, we're just going to show you all the Claude Code AI tools that people are using. And I was like, this is really cool. And for a second, I was starting to think, like, man, am I getting left behind because I have no clue about these things? And I don't really have the time to start learning about these things because, I run so many other things. And then I thought, no, this is just how things work. And not to knock it, I think it's very cool that people can come up with apps with backends and authentication and hosting and whatever really, really rapidly. That's really cool. But the key thing behind all of this is, are you creating something that people actually want to use? I think it's almost like when you're selling shovels to people, like digging for gold. I think a lot of these companies create these cool vibe coded whatever things because everyone thinks that's the rush to go into, not knowing that you actually have to have good ideas. You can't just start like coding stuff that no one's going to use. Thank you, Ryan. Ryan says AI code is horrendously insecure and potentially copyrighted as well. Exactly. Yeah. So, yeah, I had to like have this self-reflection moment of, I'm not knocking it. It's very cool. But also, I don't feel bad for myself for not getting involved with it right away. I don't feel like I'm being left behind because at the end of the day, I think you still have to have great ideas. Executing this stuff used to be, this used to be somebody's job. It used to be a team. I remember in the day, if you wanted an app, you'd have to send someone in the Ukraine like $20,000. And then they would hire a team of other people to write all this code. And then it probably was secure because the Ukrainians are like the best fucking hackers in the world. But, yeah, it's cool. So yes, I have heard about Supabase and these things. I don't think I'm going to get involved with them just yet. Just because I think I do like more big picture stuff these days. Anyways, I hope this was helpful, Starprod. Holy shit, my ears. Yeah, that I do need to turn that one down. That's Chewbacca. Chewbacca's way too loud. You're very welcome. Okay, cool, great. All right.
Well done.
That being said, I think, Starpod, I think it was you, right, who was talking about maybe recoding this in, I don't know, Node.js or something. I think I gave you all our source code, right? I had to retract some of the API keys. I can't be giving you all my webhooks. But totally cool. Totally cool. Yeah, if you just want to like look at it as like a project, I think it would be cool to adapt this in a more AI modern style, but I just wrote this all in PHP. It just works. And when I say I wrote, ChatGPT really wrote it, but I at least understand how it wrote it because I understand PHP. And I do have, and yes, I do have my, you know, my secret keys on an htaccess file. Like, I understand that at least. Yeah. Yeah, environments are important. All right, Spencer, you're up next. Let's do your question, Spence. And then Shantrix, and then I'll do some of the duplicates or the other people that have already asked questions before. Did I not give you points yet? 1 sec, I'll do it. Give me 1 second, Star. I still have to like drag the question into your solution. Yes, you get points once I drag the solution in. But good reminding me. I do forget sometimes. It's Starstruck, right? Is that your name, Starstruck? Did I get that right? Starstruck? Starstruck. Oh, this star. Okay, never mind. Wrong Starstruck. Why did Star not come up? Is your name in like... No, it is there. Okay, whatever. There you go. Good. Okay. All right. Let's see what the next question was. Again, if you're just watching us today, what's the best tip I have for logarithms? I think I have a video on logarithms. 1 sec, Spencer. 1 sec. Let me show this person on I think it's on TikTok. Yeah, I have him on TikTok. Right. All right. If we go to our TikTok page, here we go. How to use log rules for tricky expressions. So if you want to know how to deal with logarithms, go watch this video. Logs are the inverse of exponents. They are, Ryan. Yeah. So go check this out. It's how to use the log rules for things. All right, Spencer's with some limits. I love limits, by the way. Cool. Let's do these. These are fun. Where's Zach? Zach is my limits man. He's also my like sequences and series person. Coyotes, let's go. I don't know what school the Coyotes are at. It's using the squeeze theorem. Okay, totally cool. So I feel like when I see something like this, Spence, I feel like I want to break it up into two different things. Slant asymptotes. Yes, Alex, I definitely can. If you want to submit a screenshot of an example slant asymptote question you have, I can totally do it. The other thing I would recommend, if you have time to go through my TikTok, I have a whole video on asymptotes. Where is it? No, intermediate value theorem. Where did I do it? Where did I do the asymptotes? Here we go. Yeah, how to find, I want to say horizontal asymptotes, right? This one? So this is how you find slant asymptotes using limits. And then I also have a video on how to find slant asymptotes just using like the hack. There are some hacks that make this easier without doing it with the limit definition, so you can go check these out. But if you have a specific question... Yeah, no, you're okay. Yeah. If you have a specific question, you want to submit it to our Discord. I'm going over questions live for the next hour and a half. You can use this website to drop in a screenshot. Obama TikTok video. Yeah, well, slant is like kind of horizontal. It's technically not. It's technically not an asymptote, but whatever. It's oblique. Yeah, dude, I learned something about complex numbers from a brain rot. I bet, dude. Yeah. Dude, the brain rot stuff works wonders these days. Okay, so here's the issue, right? I always like to say, like, whenever you see a limit, what's a nice thing to do right off the bat is just take whatever the limit's approaching and plug it in and see what you get. So I have the limit as x approaches 0 of 1 minus cosine of x over tangent of x. And you may ask yourself, why can't I just plug in x is equal to 0? I'll show you why. This gets you 1 minus cosine of 0 over the tangent of 0. Cosine of 0 is 1. Tangent of 0 is 0. And so what you end up getting is 0 over 0.
Oh shit, not good.
So this is bad. You can't do this, right? So when that happens, we got to be a little bit more clever with some sort of like algebra tricks to figure it out. Spencer has given us a hint by saying that this is already a squeeze theorem question. And what the squeeze theorem says is that if you can prove that this expression is always greater than something and it's always less than something, and then the things that bind it on either side go to a single value, then this will also go to that value. Exponential log equations. I don't know what the different named methods are. If you want to submit an example only, I can take a look at what you're talking about. Example questions are the best way for me to learn. So, whenever I see cosines and tangents, I think I want to write everything in terms of sine and cosine. I think that's what I want to do, right? So I'm going to say tangent, I know, is equal to sine over cosine. So let's plug that in and see what we get. So that would be 1 minus cosine of x all over sine of x over cosine of x, yeah? Which, when you're dividing by a fraction, this is the same thing as multiplying by the flip, right? Keep, change, flip. So then this is cosine over sine of x. And then let's see what we get here. So then I get 1, so I get cosine of x minus cosine squared of x all over sine of x. I yearn for symbols to move themselves. Yeah, dude, mathematic fanatic. Yeah, you know exactly what I'm talking about, right? You're writing all the Manum code, right? For them to just like move things, it would be so nice. Yeah. Let's see. Does this help me out? This is 1 minus 1 over 0 still. Fuck. Let's think. Squeeze theorem. Yeah, you can have, soft mechanics is fine. I don't know what soft, is soft like the opposite of hard? No, I well, they said they want us to use the squeeze theorem. Otherwise, off the bat, I would have used L'Hopital's right away, right? Because this would just become secant squared, and then this would literally just become, what is it, negative sine, and then we're done. Why can't you turn 1 minus cosine of x into sine of x? So you can turn 1 minus cosine squared of x into sine squared of x. This is valid. Okay. So, all right, we are allowed to use, these are special ones that we know, right? The limit as x approaches 0, I think if sine of x over x is equal to 1, right? Or it's equal to 0. Wait, no, it is equal to 1. And then of 1 minus, 1 minus cosine of x over x is equal to, this one is 0. Okay, cool.
Good job.
Let me see if I remember why this is. Because the way I would think about it here, right, is that, like, sine of x is bounded by 1 and negative 1, right? This is the typical thing for this, right? And then I think I just divide both sides by x. Oh, this is the infinity argument. Yeah. And then, all right, right. And this is the limit as x approaches infinity. And then this is 0 is less than or equal to sine of x over x, and then this is less than or equal to 0. Okay. Yeah, that one doesn't. These are the limits at infinity. Fanatic says, I see both of those limits with their Taylor series. Okay. So... let me think. How do you use this with the... The mathematician says, hey, dude, I'm developing insomnia in my body because of stressing about a scam. I hope about an exam, not a scam. Scams are not good. I would say don't be stressed about scams. If it's someone says that they claim they have pictures of you, like, masturbating, that's false. They're just trying to get money out of you. It's not real. Okay. I want to figure this one out, though. If I had 1 minus, okay, sine of x over x is equal to 1, but I don't have any x's anywhere. I mean, can I make the small angle approximation? This is like the physics bastardy trick, where sine of x goes to x as x is much less than 1. Because then that would help me out. I thought I knew the squeeze theorem. A 5,000 foot, yeah. So this here, let me just get like an image of it real quick. Yeah, I agree those limits are handy. She really has your video? Why did you send someone your video, dude?
Surprise, motherfucker.
I would say also these days, nothing matters. It's okay. You can still become president, apparently. Doesn't matter what you do. There's a really pretty picture of this. Or I guess Wikipedia, dude, I hate Wikipedia. I really don't want to use Wikipedia. Wikipedia for math is terrible. If it happened 1 year ago, then you're fine. If nothing's happened yet, it's not going to happen any other time. Just add a Sora AI to the videos you send. Yeah. So this is an example of the squeeze theorem. Okay. So let's say, for instance, that this green function here, I don't know. Let's just say this thing is g of x. And then let's say that this thing down here is h of x. Okay. And then let's say that this thing right here is f of x. Okay. If you can prove that this blue function f of x is always less than g of x, but is always greater than h of x, and then if you can show that there is some value x, for instance, that when you approach it, h of x and g of x both approach the same value, which in this case is when you get close to like 0. H of x goes to 0, g of x goes to 0. That then means that f of x has to be squeezed between 0 and 0. So f of x also has to equal 0. Yeah. Radicals, Justin, I have a video on it, but if you want to submit a screenshot and add it to the queue, I'll get through it. Let me see. Mathematic Fanatic says it can turn into 1 minus cosine over x times x over x times cosine over x, and thus it is 0 times 1 times 1. You gotta be tricky with that, though. Mathematic Fanatic, because 0 times 1 as like... I don't know about like multiplying, if you're allowed to do that. Like, for instance, I don't know, 1 over 0 times 0. I don't think this is 0, because this thing is like approaching 0, and then this thing is approaching infinity, and then the question becomes like which one approaches the other extreme faster. Okay, 0. Okay, all right. Maybe you are right. Okay. Oh, okay. I was thinking about infinity times 0 then. Okay, that is the 1 over 0 times 0. Okay, 1 times 0 is definitely still 0. Okay, you're trying to split things. Okay, that's fine. Let's do it. And then multiply values to get a number. Okay. So I think what we had here, right, is you have this, right, so far. And then what are you multiplying by x over x? Is that what you're doing? Such that now you get 1 minus cosine of x over x times x over sine of x times cosine of x. And then the limit of this... I'm sorry, this is as x approaches 0, not 1. Oh, exactly. Oh, very cool. Okay, so yeah, so I just multiplied by 1. You're allowed to multiply by x over x. Same thing as multiplying by 1. Okay, very cool. So then this one, you know, is equal to 0. This is equal to 1 over sine of x over x. But then this limit is equal to 1. So whatever. And then this is times 1. And then, okay, sure. 0 times 1 is 0. Why 0? For which one? Because I think that's just the definition of this limit. The first one is 0 over 0? At the beginning it is. Jeff says, I don't think so. Okay, one sec. 1 minus cosine of x. Yes, but you could do L'Hopital's. L'Hopital's is the correct way to do it. But we're doing it with... Oh, 1 minus cosine of x over x goes to 0, not to 1. Sine of x over x is 1. Wait, no, we do have this right. Yeah, we're not L'Hopital'ing. We're not L'Hopital'ing at all. You could you could L'Hopital at the beginning though, right? Because if you plug in 0 into here, you get 1 minus 1, which is 0. The tangent of 0 is also 0. 0 over 0 is valid. That's legit for L'Hopital's. You can I don't think you can L'Hopital 1 over 0. Can you? It has to be, oh, I guess 1 over 0 is indeterminate? No, 1 over 0, no, you can't. You can't L'Hopital 1 over 0. You can L'Hopital infinity over infinity or 0 over 0. Yes, there you go. Yeah, okay. Okay. I think we're correct here. Jeff, do you see? Sorry, is there some? It's okay. It's okay. You're okay. You're okay. So I think this is right. So we turned this into sine over cosine. So we got this, and then I multiplied by x over x. So then this is 1 minus cosine of x over x, which the limit as x approaches 0 goes to 0. This is x over sine of x, which is 1 over sine of x over x, which goes to 1. And then cosine of x just goes to 1. So 0 times 1 is 0. Yeah. Sorry, there's a lot going on in the chat. I can't follow everything. But I think this is correct. If we don't believe me, let's go ask my best friend ChatGPT. Let's go ask my best friend. I'm pretty sure I'm right. Oh, too funny. It does the small angle approximation. Yeah, it's also 0. Okay, great. Yeah, that sounds like a trap. Sounds like the FBI is trying to catch me with somebody's inappropriate videos. I'm not trying to do that, dude.
No.
Don't do it. Although I do remember you from previously, so this would be a long play by the FBI if they're really trying to get me. All right. I agree with that one. Let's do this one, which was the limit as x goes to 0. I'll do a different color for this one. Let's do blue. You missed Calc 1 and 2? Yeah, they're good days, dude. Yeah. What are you doing now these days, Muhammad Kazi? Are you in Calc 3? Or are you like done with school? And it's 2x squared. Interesting. So I feel like Mathematic Fanatic, I want you to. Aren't you still working on that? Isn't that like your project? It's like your baby, right? I love that one. Like, I love that you're doing that. All right, so this is 1 over 2 times 1 over x times 1 minus cosine of x over x. This, I think, is infinity. Or this is undefined. This limit does not exist. Oh, you work in electrical engineering. Cool. Correct, Ryan. You are correct. Yeah, they're inverses of each other. Yeah. Like x goes to y, y goes to x. I'm going to put out a TikTok video actually next week based on trig functions and inverse trig functions, because I do think that's a really important thing that gets kind of like messed up. I like to say like, so like sine takes an angle and gives you like a ratio, like whatever, like opposite over hypotenuse. Whereas like arc sine takes a ratio. So for instance, some opposite over hypotenuse and spits out an angle. So that's how they're inverses of each other, literally. Yes, the top and the bottom both have to approach 0. The top and bottom both have to approach infinity. Small angle approximation. Well, Jeff, I think we still want to use these. Which, I mean, here's the issue. This for sure goes to 0, but now I don't like this. Because 1 over 0 is like infinity. You think this should be 1/4? Huh. I think by L'Hopital's, right? So here's the example of why you could use L'Hopital's. We're going to do this in green, right? If I plug in 0, I get 1 minus the cosine of 0 over 0, right? 2 to the 0 squared. This is 0 over 0. Which means we're okay to use L'Hopital's, right? Which means I'm going to take the derivative of the top, I'm going to take the derivative of the bottom, and we're going to see what we get. So derivative of the top would end up being sine of x, right? And then derivative of the bottom would be 4x, right? Plug in x equals 0. Now you get sine of 0 over 0, which is still 0 over 0. So you're not done, but you can still use L'Hopital's rule because this is 0 over 0. So then you take one final derivative of this, which would get you cosine of x over 4. And then if you plug in 0 here, now you get 1 over 4. I think 1/4 is the correct one. Cosine's adjacent over hypotenuse. Sorry, wait. I agree it's 1/4. How do we show that, though, with this quote-unquote squeeze theorem thing? Oh, you're okay. Yeah. There's a lot going on. TikTok's fucking vibing today, dude. What's up, TikTok? I agree it's 1/4, but is there a way to prove it? Yeah, L'Hopital's is dope. I love L'Hopital's. Is there a way to prove it with this stuff? I think is the question. I could do a power series. I really don't want to do a power series. Okay, what if I multiply the top and the bottom by 1 plus cosine of x? Yes, but Ryan, there's also some weird, the flipping by 180, there's some weird restrictions on the arc functions. For instance, arc sine is only defined in quadrants 1 and 4, whereas arc cosine is defined in quadrants 1 and 2. The domains of them, sorry. The ranges. No. Yes. The ranges. Yeah. I don't think we're allowed to you tell me, Spence, am I allowed to L'Hopital, or do I have to? I think the key thing in this homework is I had to use the squeeze theorem, which I guess these are done by the squeeze theorem. Yeah, I don't think we can use L'Hopitals. So here's what I'm gonna do. I'm gonna multiply, and I think JC has, mathematics. Yeah, let's do this. Let's multiply this by 1 plus cosine of x, 1 plus cosine of x. Right? Then that's going to give me 1 minus cosine squared of x over 2x squared, 1 plus cosine of x. And then 1 minus cosine squared of x is equal to sine squared of x. Right? And then this is 2x squared, 1 plus cosine of x. What are my credentials? I have a PhD in physics. If you ever want to figure out, like, more about me. So the website where people are submitting their screenshots, actualofficehours.com. If you click here on bio, you can go read my thesis and check out my LinkedIn. Ooh.
Oh, yeah.
You are so right, Jeff. Love it, Jeff. Very nice. Okay, so this is 1/2 times 1 over 1 plus cosine of x. Very good. Times the sine of x over x squared. Right? Yeah, sine squared x over x squared is the same thing as sine of x over x squared. Bingo. I see where this is going to come in. So now the limit as x approaches 0, this is going to be 1/2 times 1 plus cosine of 0. Cosine of 0 is 1. So that's times 1/2. And then this is a special identity, which we know is just going to be 1 squared. So you get the answer 1/4. Oh, nice. That's sick. What's up, Obi? And Mean Machine Rex on the 3 stream streak. Shout out to Obi. Obi's another awesome streamer. He does math as well, and he's from across the pond. I was going to say, Obi, I think we're if the world keeps going the way it's going, I think we're the last allies. You're the last European allies for us at this point, or something. I don't know. There's some like weird shit coming across my algorithm these days. I was like, wait, what? The United Kingdom stands with the U.S. at least. I don't think many people in the U.S. stand with like the U.S. at this point, but UK isn't. Yes, it isn't, Jeff, but it's geographically pretty part of Europe. Oh, I see, Ryan. Yeah, okay. Is the current bill... Am I a good programmer? Well, so that's such a loaded question these days. Because I feel like the best programmers these days don't even know how to program. I see these kids, dude. I told you. I get all these... Dude, fucking Gen Z broccoli hair boys, like, telling me that... I don't know. That I need to be using Supabase and, like, this and this and this. And I'm like, whoa. You guys are really ripping it these days. So I think those people like can, being a good programmer is actually not defined by what I think it used to be. I think being a good programmer nowadays isn't defined by like, do you know how to code? I think it's defined by like, do you know how to think like code? Do you stand with us? I don't know who us is. Yeah, it's the human's last hurrah. Yes, exactly. Okay, let's try to do this one. I have a hunch that this is a double angle identity question. Yeah, coding is a lot of logic. I think logic is cool. You're in the United States? I'm in the United States, yeah. I mean, I genuinely believe in the United States, as problematic as it is sometimes. US is great. There's a reason everyone tries to come here. Except our healthcare situation, dude. What? Everyone goes to Mexico to go get their healthcare, or Canada. I think this is. I think I want a double angle. Do you think I want a double angle identity here? I'm trying to think. 6x and 4x. Oh man. I think I need a double and a triple. You don't need any identities? Oh. Oh, okay. Yeah, actually, you're... yeah. Dude, yeah, okay. Dude, I'm... Oh, man, dude. I didn't even listen to the... Dude, I said this at the beginning of this question. Oh, we didn't have to go that far. Just plug in 0 into this. See what you get. You get the sine of 0 over the cosine of 0, which is equal to 0 over 1. Answer 0, and you're done. Nice. Very cool question, Spencer. I appreciate it. No says, bro, you helped me out with a retake for chem balancing question test. I barely passed a test, but I had an 8 out of 30 on the first try. Congrats, dude. I'm glad you're passing at least. That's awesome. Good job. You should be proud of yourself. Improvement is the most important thing. Don't compare yourself to others. Compare yourself to who you were yesterday. Right. This was Spence's. Thank you. You're very welcome. No, thank you, Spencer. It was really fun. I really like those questions. Again, make sure, go to the website, actualofficehours.com to submit your screenshot. Also, join our Discord, because what happens is every time we do one of these questions, I'm gonna drop it in our Discord. So let me mark Spencer's is done. So if we look here, I need to like refresh this. There we go. Cool. Here's Spencer's question. And then what I'm going to do is I'm going to download this, and then I'm going to post a screenshot in it. And then Spencer, if you're in our Discord, you'll get credit for this. It's also another good reason to join Discord. But where's Discord? Where'd it go? Where'd it go? Where'd it go? Wait, what? Where the hell did Discord go? There it is. Yeah. There we go. All right. Yep. Solution gets posted. There it is. Chem honors is hard. Yeah. No, definitely. You should, and don't be too hard on yourself if you didn't get it like the first time. My one friend had to pass calculus 3 times. It took him 3 times to pass calculus. Now he makes like $300,000 a year doing like plastics engineering. So, yeah. Oh dear. Oh dear, mathematic. All right, let's see. What else I got? Shantrix. Shantrix has a math competition question for us. Let's do yours. All right. A line has an equation y equals mx minus 50 for some positive integer m. The line passes through the point a comma 0 for some positive integer a. What is the sum of all possible values of m? Interesting. Okay. And they all have to be integers. This is kind of the interesting thing. So, mx minus 50. Okay. So, the minus 50 part at least tells me that the y-intercept is way down here. Let me make sure. YouTube sometimes like messes up. Okay. So this is negative 50. Yo, what's up, Anubin? Thanks for the sub. Hope you're doing well. Right, and then we need this to be equal to 0. Right, okay, so then this is a line. But it has to be integers, right? So this is like y is equal to mx minus 50. Positive slope means it's going to be doing that, but it'll do a bunch of these things, right? Depends on like what m is. You can just tell me what your Discord name is. Like, comment on the post. Yes. Right. Okay, but then, yeah, okay. When this is equal to 0, this is then equal to A. Got you, okay. So, right, because this would hit somewhere at A, comma 0. So you have 0 is equal to MA minus 50. 50 is equal to MA, but then these need to be integers. Oh, very cool.
Yeah.
Oh, this is just matching up a bunch of pairs then, right? So I need two numbers that multiply to 50 that are integers, right? And they want to know the sum of all possible values of M. Oh, okay, great. Okay. So yeah. Would M and A have the same values? No. Because if M equals 50, then A would equal 1, right? If the slope here is 50, then this will hit at 1, comma 0. Yeah, exactly. They're in different orders. I do know linear algebra. Yeah. So, for instance, yep, you're right. So, you could have 50 and 1. I mean, the way to do this is just do like a factor tree, right? 1, 50, 2, 25. 3 doesn't go into it. 4 doesn't go into it. 5 does. And then, yeah, we're approaching the end here. I think that's it, right? 1, 50, 2, 25, 5, 10. Is there anything else that goes to 50? 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't. Okay, cool. So, yeah, so then you could have, right, 10 and 5, 25 and 2, and 50 and 1. So then this is the sum that you need. Boom, 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 boom. Can I explain it? If you have a question, like a homework question on it, I can do it. For me to just do a lesson on something, I don't really do that on that stream. On this stream. That being said, George, there is another streamer on Twitch who is literally doing like a linear algebra course. Like, he teaches linear algebra, and I think he's about to get to eigenvectors and eigenvalues. So if you want to join our Discord, I can, and then like ping me. I can point you in the right direction for who that is. That does linear algebra. Yeah. This stream we mainly do to like help with homework questions, less so to like, we teach along the way. You know, as I do the question, I try to teach like what's happening in the question. But in terms of, can I explain a concept and just do it? Not so much. Just because it takes a lot of time, and I don't have the most time in the world. No, I do though. But George, yeah, there's literally is someone who's literally just doing lessons on linear algebra. If you have a question, George, like if you have like a test question or a homework question based on eigenvectors and eigenvalues, you can 100% submit that, and I'll do the question, and you can ask about it as I do it, and then I can explain kind of like what's going on. That's totally legit. Yeah, like help me help you. Anyways, I think you just add these up. So that's going to be 50 plus 25. So what is that? 75, 85, 90, 92, 93? Is that the answer? Shantrix? Is the answer 93? It is. Nice. Good job, Chance. Nice, dude. Okay, now you can go to sleep. I know it's late for you. Definite integral, area under curve. Those are all great things. I mean, there's a bunch of different definitions for it. I mean, yesterday we did, someone asked about kind of like a Riemann sum definition for it. There's the limit definition of an integral. Again, it just helps to see an example of what you want to know. Example questions help me a ton, because then I know what level you need to learn it at. Okay, but anyways, there you go. Great. There's a point, Shantrix, for you. I put all the points next to your questions. I can help you with your... Yes, homework I can 100% help with. Submit a screenshot of what homework question you want help with. Try to pick, like, the hardest one that you don't get. All right, let's go back to Gladiator. Leos. Good night. Yes. Night to you, Shantrix. Yeah, we do this stream a little bit later. Mostly because that's what the analytics say for me to do. Also, I like to kind of like relax a little bit in the afternoon, but the analytics say that like Sunday at 6 p.m. is the peak time to stream to like help people. Like the most people would be online, so that's kind of what I go on. Yeah, it's 10. Yeah, I understand it's late. It's just the nature. Apparently, like Sunday night, people are always hitting us up. We do have friends that stream at earlier times. I have to stream this late during the week because I have another 9 to 5 job. But if you ever want to, again, I'm not the only person that does this. If you go to the website where you submitted your questions, you can click here on streaming schedule, and underneath the schedule, there's a beautiful calendar filled with events that are happening from other math streamers, science streamers that we work with. So looks like Zach's gonna do some software development tomorrow, and then I think Zach does math Q&A early in the morning on Saturdays. He does it at 9 a.m. Is there nobody else doing math Q&A yet? This is Diffie Q. I might have to ask some other people if they want to like run their own streams helping out. And again, I'm happy to like give you guys my stream key if you just need the 1,000 subscribers so that you can finally stream. Like, we can just do that. All right, let's do this. You have a 1 meter long copper wire. You want to make an N-turn current loop that generates 1 millitesla of magnetic field at the center. When the current is 1 amp, you must use the entire wire. What will be the diameter of your coil? Okay. I think there's an equation for this. Isn't it like B is equal to mu naught I N A? Is that what it is? Is this what it is? Mu naught N I A. And then A is the like the area. I think this is the area. Also, I get confused when they say like solenoid versus loop. Like N turns current loop. Let's see. Yeah, this is what I'm talking about. Where is it? If you typed it out, it would get lost in the chat. Cabbed. So, yeah, try to take a screenshot. I know you have a phone or something. You have something with a camera on it. I know you do. Yeah, the chat's not the best place. Everything gets lost in chat. How do you send a question? actualofficehours.com is a website right down there. Here we go. Yeah, this is it. So it's not this. I was thinking about. I think I was thinking magnetic field for a solenoid. What's up, nerds? What's up, Psychode? Morning to you, yourself. Yeah, I'm thinking about this magnetic field solenoid equation. Yeah, it turns out that's this one. One sec. Yeah, that's this. So a solenoid's different than a loop. A solenoid is like a bunch of loops that have like a certain length or something. Yeah, here, this is it. Yeah. I'll put this on the page as well for you, just so you can see it. Or maybe this one's better. I think I kind of like this. Let me get this image for you. Just for later in case you need it. Yeah. Solenoids are different than coils. I think coil assumes that it's not like appreciably like long or thick. And we're just... Because where this comes from is like, so B for a loop of wire is equal to mu naught I over 2r for a single loop. So if you have a single loop of current here, this is going to create a magnetic field that's equal to this. And this comes from using BO_R. It is math live. Well, this is physics live right now, but we do math. Yeah, we do a lot of math. This comes from this, right? dB, I think, is like equal to, I want to say it's mu naught di cross r over like r to the third or so. It's something like this. But from BO_R, you get this if you integrate across an entire circle. So that's for a single loop. But then if you stack the loops on top of each other, then you have n numbers of magnetic field. So that's why the magnetic field is n. Yeah, the equations are kind of different though, Psycode. Right? Because this one is mu naught I, and then it's n, which is the number of loops per unit length. You know what I'm saying? Where this refers to, like, this is r. This is referring to, like, there's no r in here. And actually, how they do this for number of loops per unit length, right? Then you start thinking about, like, for instance, if this is like a cross section of my wire, like, what is the radius of my wire? Because then the number of wires you have stacked next to each other, the radii of those wires will determine the number of loops per unit length. Okay, you're okay. Yeah, so I don't think you need to deal with solenoids yet. I think this is literally just this. For a single loop, this is for a single loop. You will learn this. Magnetic fields are crazy. They are pretty dope, dude, honestly. They're dope.
That's dope.
Yeah, they're really dope. You do have a point. I sometimes have points. I sometimes have lines. I sometimes have circles. Okay, so for a single loop, it would be this. So for n number of loops stacked on top of each other, it's going to be n mu naught I over 2r. So, interesting. There's actually kind of a... Okay, so n is related here, though, right? Okay, so this is actually really cool. This is a fun problem, actually. I do like this. So you're told that you have a meter long, all right? So that means that depending on... So the amount of loops you can make depends on the radius of the loop, right? If this is r. So if we think about how much length gets used to make that one loop, that's the circumference. So in this case, L is equal to 2 pi big R, right? And then so N times L, which is equal to 2 pi R N, that has to be equal to 1 meter. Because I only have a meter of wire to, like, make loops. So actually, this is cool. So this tells me right off the bat that N is equal to 1 over 2 pi R, which I can now substitute into here, because as I looked at this, right, this is a problem. I have the magnetic field, I have the current, I'm trying to determine the diameter of my coil, which I can get from the radius, but I don't know N. So I have too many variables that are missing. So I need another variable that connects N to the length of wire that I'm allowed to work with, or it connects N to R. And this is the connection. That N is equal to 1 over 2 pi R. Because 2 pi R, which is the length of wire in one coil, times N number of coils, has to equal 1, or 1 meter. Does that make sense, Gladiator? Let me know if it doesn't. I can explain it again. Or if anybody else watching, if this is, like, confusing as fuck, just tell me. I'll go over it. That's the point of this. Most times in class, your teacher would just wave their hand and just be like, yeah, we're just going ahead. Okay, good. Cool. Makes sense. Awesome. All right, cool. Because this... Okay, now this is... All right, this is interesting. So, I replaced N with 1 over 2 pi R. Then I have mu naught I over 2R and I have B. So then we're just solving for R here in this case, right? So that tells me that R squared is equal to mu naught I over 2 pi B. Or 4 pi B, sorry. Because there's two 2's. All right. Mu naught is, oh man. It's 4 pi times 10 to the minus 7. I know that. That's mu naught. I was equal to an amp. Nice. They give us nice numbers. Love that. And then we say 4 pi. And then B in this case is a millitesla. Beautiful. So 1 times 10 to the minus 3. All right. So then we just got to solve. Solve. Let's pull up the calculator. You are? Wow, Minnie.
My man.
The algorithm is working. Actually, cool thing here. We have a 4 pi and a 4 pi. So this actually goes away. Think smarter, not harder. I don't even have to deal with this shit. Oh, this is super easy now. Oh, I don't even need a calculator. Thank you. Yep. So this is 10 to the minus 7 over 10 to the minus 3, which is just going to equal to 10 to the minus 4. Because you subtract exponents. So negative 7 minus negative 3 gets me minus 4. That's equal to r squared. I was blackjack gambling? What? What are you doing? You're playing blackjack. Okay, and then to get r, take the square root of both sides. So then you get r is equal to 10 to the minus 2. This is where knowing your exponent rules will help you. So the diameter, so r is equal to 0.01 meters, or a centimeter. So diameter is equal to 0.02 meters. And you're done. Nice, great question.
Well done. Well done.
Oh, a solenoid assumes L is much greater than R, so the uniform field inside. Got you, that's why it is. Thanks, that actually helped. Sick. Love it. Yeah, Gladiator, when I post this in the Discord, just use your Discord username and be like, hey, I'm Gladiator. And you can change your nickname in Discord, I think. I think I gave you guys perms for that. Just change your nickname to Gladiator. Or, like, put it in parentheses or something. Just so I know who it is. Help me out. Boom, boom. Good question. Nice little mix of chemistry. Not chemistry, sorry, physics. The amount of windows I have open. Bro, if only you knew how many screens I have. 1, 2, 3, 4, 5, 6. I have 6 screens right now. This isn't even that many windows. 6. I do. Thanks, George.
Good job.
I think you're pretty cool too. Make it 7? No 6, 7.
Right.
No, we're not doing it. Not today. Not today, God. I do have a setup pick. So wait, I think I have it if I type in ! setup in Discord. Yeah, let's see. It'll pull up. There you go. Yeah, this is my. Oh, this isn't even my updated setup. Oh, this is whack. One sec. Let me find the actual setup. I have another setup picture. Yeah, that's not even all the screens yet. Sorry, let me find one more. Yeah, that was. I mean, I think it's technically 5 if you count the prompter. Is what it is. Yeah, here we go. This is it. This is what I want. There we go. This is if you walk into my lair. There you go. So yeah, there's this screen for OBS, this screen for tutoring. We got Discord. This is TikTok down here. And then, yeah, the prompter's up top there. So, a lot of screens.
Good job.
The Goon Cave. I don't know. Don't shit where you eat, man. If this was the Goon Cave, I don't think I could be in here. It would smell really bad. Yeah, it didn't start like this. I've been doing this since 2021, and the amount of equipment I started with was literally just a laptop. It's only after like 5 years. You just keep finding things. You're like, oh, I need one of these. Oh, I need one of these. No, I need one of these. I need one of these. And like, you just keep adding monitor. I actually want another monitor, but there's no more space. Also, I'm out of video card slots. I'm running 2 video cards on this PC because NVIDIA caps you at 4. Yeah. What am I up to besides tutoring? I teach physics at UCLA. I'm not teaching right now. I'm going to teach again in the summer. And then I consult for some education startups, some like edtech stuff. And I actually just got hired to a new job doing corporate sponsorships for education AI stuff. I can't really say more about it because they made me sign some NDAs. But when I get information, I'll let you guys know. Dun, dun. You need a golden setup, yeah. No, I do need all this stuff. All this stuff is 100% necessary, Mathematic Fanatic. Yeah, thank you, George. Yeah, give us a like, give us a follow, turn on notifications. We stream 4 times a week now, almost 5. Living the life. It is a life, I guess. It is fun. Yeah, I'm actually pretty grateful for it. I have a good time. Get to stream and help you guys out and pay my rent. Me to my mom begging 2K for a 2K setup for doing calculus.
Oh shit,
You're not that guy, bro. Trust me. You're not that guy.
Yeah, I feel really bad if anyone's trying to build a PC right now. The prices of RAM and GPUs because of AI. It's atrocious, dude. It's incredibly cost prohibitive to build things. Yeah, I feel bad. I'm glad I don't have to like buy components, like knock on wood right now, because that would get really expensive. All right, let's see. The radii curvature of a biconvex lens are 20 and 30 centimeters. Its refractive index is that. What is the focal length? Is this the lens maker's formula? I think it's lens maker's formula. Take up a subprime loan, dude. Seriously.
bruh.
Although, to be honest, when I was making this PC was right during COVID, and there was also kind of a big Bitcoin like frenzy, and it was very difficult to get video cards, just in general, because everyone was mining as well. It really sucked. That being said, I mined some stuff as well. I made a decent amount of money mining Bitcoin or Ethereum. You used to be able to mine Ethereum, then they went to proof of stake. You can't do that anymore. I have the worst joke ever. What is nuclear physicist's favorite meal? Fission chips.
That's dope.
Oh, that's pretty good. Okay, oh, that's a good one. That's a good one, Amir. I think that's good. That's a good joke, dude. A good joke. Okay, all right. Okay. So I think this is the formula you need to use. These are these convex? I think these are, is this biconvex? I think these are biconvex. No, wait, biconvex is this. No, that's concave. No, biconvex is this. Okay. Okay, then that's just this. Okay, yeah. I was gotta remember, like, cave means like you're concave, you're like entering like a cave. Whereas like convex is, I don't know, you're getting vexed off or something. Yeah. Okay. So what did they tell us? Oh, they gave us the refractive index 1.66. Okay, so for question A, this is n-1, so 1.66 minus 1. And then you have 1 over R1, so 1 over 0.2 plus 1 over 0.3. So it goes geometry, algebra 2, pre-calc, calc. And then within calculus, there's like calc 1, 2, 3. And then it's either like linear algebra, diffie-q, complex analysis, real analysis, and then you could do PDEs, I guess. That's another one. Okay, and this is equal to 1 over f. So I think that's what it is. So let's get some numbers for that. So you got 0.66 times 1 over 0.2 plus 1 over 0.3. And that's 1 over f. So then we gotta invert that to the -1. 5.555. I got 5.5. So then I think it's 18 centimeters. 18 centimeters. I think 18 centimeters. Okay, 0.18 repeating actually is how you would write that. At what distance must an object be placed so its image is upright and magnified 2 times its height? Ooh, cool. So magnification is equal to 2, and that's equal to negative di over do. Right? And then... Oh, that's okay. Yeah, rounding is still good. Still good. Yeah, you did probably 1/5 plus 1/3, right? And you probably estimated this one as 2/3. Oh. Okay, but then I need a relationship between di and do, right? So I know that 2do is equal to negative di. And then I know that 1 over do. And then I want to say this is... I think this is 1 over di is equal to 1 over f. Right? Which 1 over f was equal to the 5.5, right? And then you know that di is twice do. So you got 1 over do. So here's the question. Is it minus 1 over 2 do, or is it plus 1 over 2 do? I hate... Dude, the negative signs. If we could just, like, get rid of the negative signs in optics, I would be a happy man. And actually, sorry, I think it's this. I think it's di plus do. They do, man. The sign changes, and dude, especially, I think that's what annoys me the most in optics, is because they're not terribly intuitive, and no one can seem to make up their mind in, like, the physics and structural realm about, like, what they should be. And so even if I Google the equation, I don't know what convention they're using. I think that's what annoys me the most with optics. Well, at the end of the day, sorry, we want to know... Yeah, we want to know do. Yeah, I can see that too. I'm going to assume it's like this, okay? Which is then going to tell me that, right, that, so if I have 1 over 1 do minus 1 over 2 do, that's the same thing as 2 minus 1. So I'm going to say 1 over do, or negative 1 over do is equal to 5.5. For sure. So then, so do is equal to 1 over this, which I think is the same thing. So at the focal length. So I think it's 0.18. Let's check this with chat, just to make sure I'm not crazy. And this is where I totally condone using ChatGPT for this, because the minus signs is so beneath me at this point. I'm not learning anything new from minus signs, except for that how much I hate optics. No. It's just annoying. Alright, let's see. Chat's been taking a while, actually, today, honestly. Let's go to Gemini. Fuck it. ChatGPT for learning gives good prompts and say don't give the answers. Yeah, I want to see what it does. I want to see what the answer is. Oh, interesting. Oh, so I fucked this up from the beginning. Again, dude, it's the sign convention, dude. Dude, this is so annoying. Wait. Okay, bro, exactly. Dude, this is so annoying, dude. Look at this. So, again, this thing on whatever said it was 1 over R1 plus 1 over R2. And then Gemini says, wait a minute, it's 1 over R1 minus 1 over R2. But R2 is negative because it's the opposite side of the lens. Okay, whatever. Okay, so 18 centimeters, great. So they think it's both minus. Okay. So when I had this, it should have been sorry. This is minus DO. And so then this becomes negative 2 DO. Okay. Now this is different. Because now this is negative 1 minus 2, right? So this is negative 1 over 1 half DO minus 2 halves DO, which is equal to negative 3 halves DO is equal to 5.5. So DO is then 2/3 of that. Which is going to be... Well, now, interesting. Okay, no, sorry. The DO's on the bottom. Sorry, what am I doing? There we go. That's what I wanted. Yeah, it's going to flip again. Okay. Twice 1.67. I don't know if that's a joke or not. So, DO is equal to negative 3 halves times 1 over 5.5. What does that get us? .27, which I think is what Gemini got. Oh, not quite. Yeah, no, 0.27. Okay, cool. Great, so... Right, and then the object distance is negative, because that means it's to the left. Yeah, okay, so we can say 27 centimeters. Great. Okay, I might skip part 3. Just because I'm running out of time. Gladiator. Or the Star Pod. I might skip part 3. Just because I don't know what's going on here. The plano convex lens L2 with an I. Yeah, okay, I'm just going to skip this. Yeah, I can understand this. But it's cool. Yeah, great. It's fun. But not exactly fun. Alright, 30 on 30. You're on next. Bless Gemini for finally getting it, dude. Or not Gemini. Interestingly enough, actually. Sorry. What is it? ChatGPT got a different answer here. ChatGPT got that it's 9. So even ChatGPT and Gemini both are they have differing answers on the sign convention for this. Dude, I hate optics. I hate optics, man. Just hate it. Am I running out of time? No. I still got 26 minutes left. I still got time to help you guys. All right, let's see. What we got? 30 on 30. Okay. Something about quadratics, I think. Miami running out of time. Miami? Miami's not playing right now. Miami played yesterday. Amir says, my whole class is done with proofs like reason and statement. Proofs are cool. I know proofs are scary. An eye for an eye and the whole world would be blind, but at least we wouldn't have to do optics. Yeah. You're very welcome, Starpod. Thanks for asking. Yeah, don't feel bad. You can always ask those questions. I'm happy to hate myself to perfection. I need to get better at optics. So I appreciate you asking them. Okay, sketch the graph of the quadratic equation given in vertex form. Label the coordinate. Okay, so this isn't too bad. Okay. So you have y is equal to a, and then it's x minus h squared plus k, where the vertex is at h comma k. So in this case, h equals -4 because it's x minus h, but if it's x plus 4, that means h is -4. And then k here is going to be -3. So we can mark that as a vertex. So here's -4, come down to -3. There you go, vertex. Love it. This is positive. If this is positive, that means it does this versus doing this. So, I know it does this, but what's a better way, just to make your teacher happy, is to try to find, like, what the intercepts are, okay? So in this case, I think what I want to, well, square root of 6 is not going to be a nice number, is it? Yeah, let's try plugging in. Yeah, let's plug in. Well, does that work? Let me think. 16, 8. Yeah, let's do that. So plug in a point. Let's plug in x equals 0. Okay, if you plug x equals 0 into here, you get 1/2 times 4 squared minus 3. 16 times 1/2 is 8. 8 minus 3 is 5. So now you have a point, 0, 5. So you can go 0 up to 5. There's one of them. And then by symmetry, notice how this went 1, 2, 3, 4 over to the right and went up to 5. This will go 1, 2, 3, 4 over to the left and also go up to 5. So there you go. That's your final thing. Yes, this also gives you f of -8. Exactly, Jeff. Yeah. This is also called the axis of symmetry. This is sometimes called the AOS. And that means is like whatever happens here is a mirror copy over on the other side. Okay, rewrite the equation you just graphed in standard form. Okay, standard form's not bad. Standard form means it needs to be ax squared plus bx plus... I could, Jeff, but I don't want to. Well, I just don't have the time to do it. I want to see how many of these questions we can get through before we run out of time. Okay, ax squared plus bx plus c. So we're going to FOIL this out. So this is going to be 1/2. This becomes x squared plus 8x plus 16. And then minus 3. So then the standard form is going to be y is equal to 1/2 x squared plus 4x. And then 1/2 times 16 is 8. And then 8 minus 3 is 5. And there you have it. Nice.
That's dope.
Hope that helps you. 30 on 30. Fun question. Then we got Pi, then Cyber Mage. Y-intercept is 5. Yes, and we could see that actually, right? From the equation. Next, we are solving the Riemann hypothesis. Dude, every week, we get closer and closer to solving the Riemann hypothesis because somebody asks me about it and I think about it more. So technically, humanity is getting closer to solving the Riemann hypothesis because I am thinking about it more. Yes, right. If these things are 0, you get y equals 5, and so that checks out. That is the same y-intercept. Yes, all of these streams, Alistair, have been just leading up to solving the Riemann hypothesis. It's my grand plan for you all. I'm just gonna solve the Riemann hypothesis. Just a little bit more gold, and it might be. Yeah, maybe that's the answer. Just more gold. Ooh, this is a fun one. Who gave me this integral? Solve the Navier-Stokes. That's another Millennium Prize, no? The Navier-Stokes equation? I'm pretty sure it is. Is this the log of sine of x dx? Ooh, side code. What do you got for me, dude? Alright, so the log of sine of x. This does look painful. Do I need to use a power series for this? Is this solvable? Okay. I'm trying to think. Do I need the Euler form of sine of x? Oh. It goes to infinity at 0, so it's non-trivial. Oh. I mean, you do bring up a good point, right? So if I were to put this into the equation, the issue is then I'm taking the log of the sine of 0. Sine of 0 is 0, and the log of 0 is undefined. So I think technically you have to take a limit as a approaches 0, and then you would say like from a to 1/2 pi over 2. Use the King's rule? Interesting. Wait, what? What is the King's rule? I've never heard of this King's rule. Wait, excuse me, what? Alistair, what are you saying? King's rule? I didn't know about this one. Oh. Yo, what? Where the shit this come from? In all of my 10 years, sorry, 15 years probably of teaching calculus, I don't think I've ever seen this. Thank you, Psycode. You taught me something new today. Oh, fun. Okay. So the integral of f of x from a to b is the same thing as the integral from a to b of f of a plus b minus x? Oh, it's not your question, Psycode? Oh, I thought it was yours. No, it's definitely going to help us. So a to pi over 2. And then we're going to say log of sine of a plus pi over 2 minus x dx. Does it actually work? I mean, apparently it's a thing. Apparently this is a thing. There's a derivation for it, I guess. Right, and then I see how this is going to work. This is super cute. Wow, it's so funny. What's up, Alistair?
Yo, what's up?
What's up,
Glad
Alistair?
I brought up. Okay, so the initial integral, yes, label it as I, and then the initial integral, label it as I, and then hang on. Wait, stuff's not loading, so hang on, stuff's not
I think sine of pi over 2 minus x is the same thing as cosine of x, no?
yeah. No, sine of pi over 2 minus x.
Yeah, it's the same as same
Hang on.
thing as cosine of x.
Same as cosine of x, yeah. So when you add that to the original log of
Yeah.
sine of x, the whole integral just becomes 2i.
Well, let's see. So log of cosine of x, right?
Also, what kind of log are we doing? Are we like doing log of base 10, or are we just doing the natural log? Because like whenever we see the standard log, it's just
It's probably ln. It's probably ln.
there's just
It's probably ln. Yeah.
Yeah.
Log in Mathland,
Okay, there we
when
go.
they
I can
just
see
write
the
that, it's
screen
probably
now.
ln. But then, how is this just 2i? Sorry, cosine of x I can write as e to the.
Yeah, we can say because
Cosine of x is equal
pi
to
over
what?
2 minus x is sine of pi over 2 minus x is just cosine of x. So
Yeah.
2i becomes the integral of log of sine of x from 0 to pi over 2 plus the integral of log of cosine of x from 0 to pi over 2. I think that's how it goes. Hang on, I'll type it in chat. So
Yeah, type in chat. Yeah,
2i.
I can't. Yeah, I can't follow exactly. I think
integral-
maybe I want the Euler
Hang
equation.
on,
What's up, Mimi?
I don't know if we're supposed to do Euler here. Pi over.
Just show me how you're getting it.
Hang on, sine of x.
It says 1 second, please.
Hang on. Plus. Oh wait, hang on. I think I should just. Hang on, I think I should just copy paste the whole thing because like typing it manually isn't really gonna help. There we go.
Jeff is like, it's still gonna be a sum.
Wait, what the? Oh shoot! Hang on, something's wrong.
Okay.
Something's wrong. Something's wrong.
Alright.
Wrong.
All right, go fix it.
There we go. Wait, something's wrong in here. Something is wrong in here as well. There, I fixed it. Hopefully it'll... There.
Okay.
I think that's how it goes.
Yes, Amit. I think you're right, Amit. Amit has the right idea, which is what Alistair literally just said. Yep, you're so right. This is what we're gonna do. So we're gonna say that.
Okay, how would the bounds change? Okay, I have a question. How would the bounds change if we like combine those two integrals using the sum rule for integrals? How are the bounds gonna change?
Well, this is the ln. So can I combine? Can I combine this then? ln of sine of x plus ln of cosine of x.
So we can use a log. So we can use some sort of log rule or something.
Right. So isn't this 0 to pi over 2? Ln of sine x cosine x.
Oh crap! Stuff is still loading. I might have to go to your Twitch. One thing I noticed about Twitch is that there's a slight delay. There's a slight delay in stuff.
Yeah, of course. Yeah. There's an encoder delay. Yeah.
Yeah, that's what I was saying. Hang on, stuff still.
All right. So this is 1/2 sine of 2x then. Yep, I agree, Kumar.
Double angle identity. I think so because like when we use log integrals,
Okay, so what's up?
No. Okay, so earlier the Discord stream wasn't loading, so I had to like stream in Twitch, but now it does. But it just doesn't load full screen.
No, there's no. This isn't no. This is someone asking me like a funny question for me to do it. I'm trying to do it. So this is ln of 1/2 of sine of 2x.
Sine of 2x. Yep.
Dx.
Yeah,
which,
that's how it goes.
And that's equal to 2i, right?
Yeah.
So wait a minute. These bounds are both 0 then, no? Right? When I put ln of
Zero
sine
to
of
pi.
sine of 0, but then yeah, sine of 0 to sine of pi. But
then
sine of
just-
pi is also
yeah,
0.
Like sine of 0 just becomes 0.
How do you know it's
Sine of pi
2i? It's because we added them together, Jeff. So I took one version I had, and I added it to the other version I had, and so that gave me 2 i's.
The other version's with the King's Rule, by the way.
The other version's from the King's Rule. Yep.
Yeah.
Yeah, the limit won't change. I'm tempted to say the answer here is 0.
How can we actually say it's 0? Like this negative area will cancel out the positive area or something.
Oh, how did I get I in the first? Oh, that came from this dude, Jeff.
Sure, it's 0.
The original expression is called I. The integral is called I.
Yeah, sometimes labeling an integral as I is just way easier. It's way more convenient than like.
Yeah, I've seen this ln trick before, where you add the integral to itself. Yeah. Sorry. Yeah, it's not an imaginary number. Do ChatGPT? Yeah, okay. Yeah, let's check chat. Actually, I'm gonna check Gemini. I've been a little bit more happy.
Trusting Gemini more
Well,
than
I
ChatGPT.
Yeah, I don't know. Chat's been kind of like slow lately, or whatever. I don't know. It's not the best. See what it comes up with. The value of this integral is negative pi over 2 log 2. Okay. So they do King's Rule. They add them. They get to this. They use the double angle. Oh, okay.
Wait, where's the one? Oh, okay. I'm gonna mute myself for a bit. It's getting a bit noisy in here, alright?
Yeah, I'll move you the audience. You're good. Fine. Okay. Alright. Okay. It's not 0, yeah. So let 2x equal t, then dx equals dt over 2. Oh, this is complicated. Oh, I don't think I was gonna get this.
Disqualified.
All right. Fun question, pi. Yeah, I see how the answer. You like keep referring it back to what the original integral is. Okay, I have 9 minutes left, so I'm gonna say we partially got this one right. But if someone wants to keep working out the answer, they can. Just in the interest of time. I think if you look at it on a graphing calculator to see the symmetries you can use. TikTok won't let you type anymore? Aw. Here, let me make you a mod. Maybe you need to be a mod on my channel. Can I do that? Can I do that for you real quick? Let me see if I can do that. Alright. You're a moderator now on my TikTok, so maybe that should give you some more permissions. Okay. Whose was this? Pi. Bono. All right, let's see. Cyber Mage. We got any fun ones here? Oh man. Heating pumps. Ooh, I don't know about this. I appreciate everyone submitting questions. It's always great to submit things, but I do not know what this is. This is some engineering type stuff. I'll put it in our Discord though, and see if there's a engineering person that can do it. It's hydraulics. Well, I don't see any. Yeah, this one looks way better. Yeah, I can do this. Let's do this real quick. Engineering hydraulics I can't do, like in 9 minutes. Oh, the keyboard won't come up. Okay, whatever. You can still stay as mod. I'm sorry, Cyber Mage. I just don't know how to do it. But I'll post it in my Discord, and I'll see if anyone else. Do you have like a test on it tomorrow? Probably not too hard, just arcane. Yeah, I just don't know what's going on. All right, let's factor. Okay, and then on the bottom, this factors out. Yeah, chat doesn't know either. Yeah, if chat doesn't know, I don't have an engineering degree. I have a physics degree, which I have done a decent amount of fluids, but that looks like kind of like specific, like to, again, like fluid dynamic stuff. Okay, what multiplies to -3 but adds up to -2? Oh, that's -3 and 1. Okay, so then we have x minus 1, x plus 3. Or sorry, no, it's x plus 1, x minus 3. I've done a decent amount of fluids. Not those types of fluids, dog. Great. Okay, so this tells me there are vertical asymptotes at x equals -1, x equals 3, x equals 4. Because the power on the bottom is bigger than the power on the top, that tells me the horizontal asymptote is at y equals 0. So then let's mark some things. So -1, 1, 2, 3, and 4. And then there's also a 0. Well, these are where the horizontal asymptotes are, sorry. Yeah, so there's one here. And then there is a 0 at x equals 2. Cool. So there's a 0 here. So actually, yeah, let's not mark these as points. Oop. Yeah, if you want to know my education background, I have a PhD in physics. I've been teaching for probably 10 plus years. I currently teach physics at UCLA. I run this nonprofit. If you want to know more about my bio, so the website actualofficehours.com. You can click here. There's a link that says bio. It has like my LinkedIn and everything if you want to know my whole background. Amit says that log Sinex question was in my high school exam. No one got it correct. No. Damn, dude. That's terrible. Okay, and then everything eventually goes to 0. So I think you have to like test points basically at this point, right? To see like where things are going. Which is a little annoying. I guess what? At 0, it's going to be negative on the top, and then that's positive, negative, negative, positive. Okay, so it's positive. No. Positive, negative, negative. Okay, so it's negative. Okay, so it must be doing this. Right? We agree it does that. And then, I don't know, right? If we get more than 2, positive, positive, negative, negative. So that's positive. Okay, so it is doing this. It's doing like that. And then I don't really know what's happening here. But then, okay, to the left, all I'm doing is I'm plugging in like values of x to see like what happens to all these different terms. And that'll tell me whether it's above or below the axis. So when you're left of -1, so let's say you're at -2. So if you were at -2, this would then become negative. This is negative. This is negative. This is negative. So negative times a negative is a positive times a negative is a negative. But then negative over negative is a positive. So that tells me it must be doing something like this. Right?
Nice.
And then where does it come from, though? think it does this. No, it's gotta be just something like this. Right, because it has a horizontal asymptote at y equals 0. Got it, okay. And then to the right of 4, let's say at 5. That's positive, 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 positive. That's also positive. So it's got to do this. Question is, what does it do in between? That's a little trickier. Yes, there are, Alistair. I need something between 3 and 4. So let's say it's just like barely bigger than 3. Right? If it's barely bigger than 3, this is positive. This is negative. This is positive. This is positive. So positive over a negative is a negative. Okay, so I think it does this. Ugh. I want to say it's that. Okay.
My man.
I think that's how you do that one. We could actually graph this. Let me get this real quick. Let me say, like, let me just here come up with I just don't want to type it. Can I copy this, please? I just want to put it in Desmos. There we go. Oh, interesting. Oh, yep. No, we're right. I had to, like, zoom out. Yeah, cool. Is physics fun? I mean, I want to go in electrical, but mechanical, but I'm not sure yet. I really enjoyed physics. Engineering is cool too. I think physics is, I mean, it depends what you want to do. If you want to, like, just get a job, then probably go to one of the engineerings. But if you like, just, like, love the game, you know, if you love just, like, learning and shit, I would highly recommend doing physics, because it's a little bit more, like, pure. And you learn, like, a cool way of thinking that I don't think you learn in like, engineering. Just, like, how to solve problems becomes less mechanical, like, less procedural, and more, like, creative. I think that's why I really went into physics, is I really enjoyed the freedom in coming up with unique ways to solve problems. And it helps you out with everything else in life, because life is a series of problems, and you're just always trying to solve them. Okay, so that was good job, nonchalant minion demon.
Well done. Well done.
Okay, cool. All right, I am out of time. So let's wrap the stream. Cool. All right, thank you everyone for coming to Academic Education Office Hours. Appreciate all the questions you guys had today for us. Lots of fun. Thanks for hanging out with us on a Sunday. Again, if we didn't get to your question, not to worry. I know there were a couple here in the queue that I just ran out of time. Do not worry. These will all get posted in our Discord. So make sure the same website you went to go submit your question, click join our Discord, and these questions will get sent into a cool special channel that I have a lot of other awesome friends that like to solve things in their free time, and they may help you out. Otherwise, there's like a bot that'll go through and give you the solution in like 2 days. Or like an attempt at the solution you can learn from. That being said, we have a new schedule this year. So make sure to click on the streaming schedule. This has all the times that we stream, as well as the other awesome friends of ours who do math and science streaming as well. So our next stream will be tomorrow, same time, 5 to 8 Pacific. So 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern, 6 p.m. Mountain. Come on by if you want to get help with your math and science questions. While you're there, make sure give us a follow on YouTube if you found us from Twitch, or give us a follow on Twitch if you found us from YouTube, or if you found us on TikTok, give us a follow on both, because all the analytics and the subscriptions and the likes and the follows, those help the algorithm determine that our content is meaningful, and then puts it on the algorithms for other people so that they can get help. Twitch math rules, yes. All right. If you're following us on Twitch, which is the best platform, I highly recommend you go follow us on Twitch. We're gonna go raid another person who is streaming today. Who do we got? Science. Dude, there's so many fun people now streaming these days. It's pretty cool. Eric, go say hi to Walking Stick. She's part of TKF. She's cool. She's talking about the physiology of whale strandings. Okay, cool. All right. That being said, enjoy the rest of your weekend. I hope you guys have a wonderful time. And we'll see you at the start of the week tomorrow. Peace.